Hi folks, we're here at Port Greville and my name is Sophie and this is John.
My name is John.
And who are they?
We got Ralph Stay, we got Denise Brushet. They're from the Department of Natural Resources.
The real one.
Hey guys, what we're going to do is we've got a beautiful exposure of an outcrop of sediment, quaternary sediment. We don't know what age. And you can see the exposure here. It's almost 16 meters of just gravel and sand. And so we're going to start at the top and take a look at each of some of these layers. We're going to end at the very bottom on the left over here. Where it's cliff forming sediment, a little bit more either cemented or fine grained. We have to dig into it to see. And we're taking a note of all the complexity in the structure here at the large scale. You can see big beds that are sort of dipping and going into each other in the midsection. Then below those, you see beds that go this way and other beds near it that's going that way. So there's a lot of complexity here, and we're going to spend some time to figure this out. So come join us. Okay, so we're at the top of the section now, or near it. I can see the soil at the top. We're going to ignore that for now because a lot of the structures that you see up there are not primary structures related to whatever deposited this. It's related to cryoturbation or pedogenesis, the soil forming processes. So below that upper soil up there, you see quite a range in class sizes from football scale, which makes it into a boulder level. Some of them are greater than 30 centimeters in long axis, but most of it is cobble gravel. It's actually moderately sorted cobble gravel. And there are some indications of bedding, some weak indications of bedding. You can see some little lenses of sand and pebble gravels in different spots. I also, Sophie and I have seen imbrication. I don't know if you could see it from your angle, but the imbrication is sort of like in the axis of my shovel right now. If you look at some of the cobbles up there, and I don't know, from your perspective, you may be able to see some others. So it's about like this. That would indicate flow direction out towards the ocean, which is not surprising. So whatever deposited this, if it was a stream or whatever, it seems to be probably flowing that way. As we come down, there's an abrupt break. It tends to be a little bit coarser in here. The matrix is still sand, but then we come to this unit, and this unit has some lenses of granular gravel right here. That's a beautiful little lens, separated by what is ranging from a fine sand, silt, and even some clay zones. So very, very fine grained sediment. Where will you have seen that before? If you've done the stream unit, you would have seen this in like a point bar for a meandering stream. That's where you get clays and fine sands mixed together. So that would be one option, is that maybe this is a meandering stream deposit, but of course meandering streams don't transport gravel, so that's not a good model to start with even. Then below that, we have some undulatory contact right in here, so it's not flat. You can see that little break here. So there's something going on, and there is some kind of a relationship between this unit and this. But in general, what I'm looking at is from here to here, it's a fining upward unit. It looks like it was very coarse gravel here. We've got some angular clasts, but for the most part, many of them are rounded. The angular ones tend to be the ones that are fractured. That could have just recently happened. But it goes from a cobble gravel to a pebble gravel to a granular gravel to this finer unit. So that's one bed, isn't it? That's one bed that's showing that normal grading here. But then below that, we've got a similar thing happening. We've got our gravels below, and I guess even though that this is a very sharp contact, we don't see that granular gravel package in here. We go from a coarser gravel down here to a pebble gravel to this fine unit. It seems like whatever is depositing this lost some energy. Is that right, Sid? Or Sophie? Sorry.
So just to summarize what John said then, yeah, we have two different units here. In the upper unit, we can see that coarse grain material, very little matrix to support it, but that's a much higher energy regime to move these huge football-sized boulders. When we move into the lower package of sediment that we've just said, as John described, is repeating itself, but to move clays and some silt, that's a much lower energy regime. And again, then we've got some granular material. So as that's coarsening upwards, there's a change from a slightly higher energy regime to that lower regime. So we've got two different processes working here over a different time period. So something has changed in the depositional record.
And then we finally come down to this brown unit. There's no doubt that that's a bed, and we're going to take a closer look at this in a couple minutes when we clear it off. Below that bed, hopefully you can see some pebble units, and if you look closely, you can see that the beds are actually dipping to the right in this photo. And then we have some coarser sediment and a very small scale bed that's right here, and then a little bit more gravel, and then another finer bed, and then some more gravel. And again, you can see these structures that are dipping towards the right of me in this case. But of critical use here is that brown bed that has a much finer grain size, and we don't know yet what its relationship to that underlying package or the overlying package. So we're going to investigate that a little bit more. And same thing with this lower one here. We can see these beds, but then this overlying unit cross-cuts those beds. So is that an important contact? Are they related? Are they same age, same process? We're going to have to look at it a little bit more closer. What else can we add?
So let's look a little bit more closely now at the contact between these two different packages of sediment that John's talked about. So you can see just where John's climbing up to now, and again repeated slightly higher, we have this very sharp contact between the overlying unit, that's that really coarse, bouldery matrix, class supported unit, and this fine grain sediment here. And you can see where John's just kind of cleaned that up for you guys. That we seem to have a lot of clay and some silt and sand there. And then immediate below it, we have again some slightly coarser grain material, a lot finer than what was in the upper unit, but there seems to be some more structure to this, and we can see, as John was just indicating, maybe he'll do it again for us, that we have some imbrication of the clasts. Anything else, John?
So if we look at it at the contact a little bit more closely, if we look at the contact a little bit more closely, I'm not seeing a lot of involvement between these two. I don't see a lot of these clasts ripped up into here. I don't see a gradational contact in that, we're going from a pebble and granular gravel here. We go immediately into something that really is a clay at the bottom. So this is not even silt. It's very clay rich. Actually, it's a clay silt, or a silty clay. So very fine, and then we get into something that's more of a fine sand, fine to medium sand, back into these wisps of clay. So in order to get that bed, it's a completely different system than than we have when we're depositing something that can move cobbles, like these pebbles, another cobble here. Same thing here, we have a repeat. We've got gravel, the gravels are dipping, and then I can see up above that it also is clay rich, silty, and fine to medium sand. That's the same thing. So very curious. It doesn't look like a diamicton, that's for sure, even though we have some class size range. We're really pretty sorted. So this would be considered a gravel. In this case right here, this material, it's a well sorted gravel, even though you see some cobbles. When you see this packet right in here, everything is within a granule range. That's a very fine, that's a very well sorted gravel in this case. Contrast that with the gravel that's up there. It's not as well sorted, but it is still not poorly sorted. This gravel up above really does still have good sorting in the sense that the matrix isn't clay and silt. Up there, the matrix is a sand. I can see that from here. And you can see that there's some evidence of bedding, as we pointed out before. So we've got poorly sorted gravel up there, but a much better sorted package down here with internal dipping units within a bed. And then we have these very sharp, laterally extensive units that are topping each of these sequences. So what kind of depositional environments would this be, Sophie? It's not aeolian. Beaches sometimes have, certainly have these kinds of gravels. This isn't as open work. It's not as clean as some beaches that we'll take a look at. But you know, at least we know it's probably water. It's not deposited directly by ice because there is sorting. It's too coarse to be aeolian. It's not just gravitational material, so it's not colluvium. So what is the depositional environment? We're going to have to take some other observations before we can actually put that together. Okay, one last thing before we leave the upper part of the section here is that I want to try to show you something that has an advantage of working in quaternary sediment, and that's that we can make our own 3D outcrops to get a really pretty precise orientation of any bedding plane. So just because we're looking at almost a vertical section doesn't stop us from seeing the 3D. And all we have to do is just erode into that sediment. And I'm eroding off this gravel first, but I can see where I'm eroding. I'm going down to this finer, siltier material. And so if I do that, again, looking at the whole thing, and we've done this in a number of places, paleoflow is about like this. Similar to the paleoflow of the upper beds, but those were more like this. This one is, in this case, if the bedding orientation is any indication of paleoflow, it's basically dipping down this way. That's the steepest part.
Okay, so we've reached the bottom of the section now, and you can just see where we were standing before, just above the fallen tree there. And now we get a really good picture of the whole of the sedimentary package. So kind of starting on the lower unit now, so we've got two units. The upper unit we saw there, that's roughly 2 meters thick, with the soil unit just above it, and then this huge package of sediment, maybe 15 to 20 meters here, of bedded material. So when we stand back a little bit further now from the previous shot that you saw, we can see multiple repeats of those beds that we saw right at the top with the clay and the granular material beneath it. But when we kind of look at across the whole section here, so 20 or 30 meters of continuous deposition horizontally, we can see that there's all the bedding planes are at different angles. And we have almost paleo flow for the first couple of meters just down from the upper unit is going in this direction. And then we can see that the flow migrates and is almost coming towards us now, so more in this direction. But then when we come right down to the bottom here and where the driftwood is, we can see that flow is moving almost directly towards me now. So we've got much complexity in how the flow has changed over time. The last thing to also note then is that there seems to be some post-depositional processes at work here as well. And this is where we can see structures that may be related to rapid ice removal from the region, and then the large-scale slumping that might be related to that, which has kind of moved and changed the orientation of some of these beds.
Okay, so we're down at the bottom left, or the sort of west side of the section, and now we have something again completely different. This is the same section, but you don't see any cobbles in here. In fact, this is a very fine grained sediment. It's very compact, and oh, there was a shell right in here. Here we go. Oh, no, that's not a shell, just garbage. That was paper from that cut. Did you see that? Oh my God, it looks so much like a shell. It was this white thing, right?
Because that acting, it was believable.
This is, oh, everybody, nobody move. Okay.
I didn't stop.
I know. Okay, so we're at the same section here at the, no, for God's sakes, what is it? Port Greville. Okay, we're at the same section, Port Greville, but we're on the very bottom part of the section. And now we have something completely different. Instead of the cobble gravels that we were seeing above, now we're into something that's very finely bedded. You can see the beautiful laminations here. The laminations go from about a medium sand up to including clay beds. So mostly fine and very fine sand and some silt beds occupying this whole thing. And one of the beautiful things that you can see in here, besides the nature of the bedding being so chaotic, some of it is here, some of it is more horizontal, but you can see some structures that suggest that they are sedimentary. So the structures being some kind of an offset here. I'm not talking about these big fractures. Those could be yesterday. These big fractures, we don't know anything about those, but I'm talking about internally in here. You can see that this lamination has been offset by quite a bit. This lamination a little bit less. This lamination a little bit less offset. The one up here is hardly offset at all. So those are sedimentary indications of deformation. In this case, they appear to be maybe normal faulting, but at a very small scale. These offsets are on the order of 5 millimeters or less. But we see them throughout the whole thing. You can see some chaotic bedding in here as well. In some places you can see little climbing ripples. If you, I don't know that this is one, but it may very well be. But we see that, but we also see lenses that pinch out and go away. You can see one right here, for example. So this is a very low energy environment. We don't know if one of these layers took seconds, or if this represents 10 years of deposition here. More likely it's going to be much faster than that, though. We can't see rhythmic beds. It's more chaotic than that. We don't see valve-like couplets, but instead we see more of a random nature of the grain size in these laminations. So overall then, we've got lots of fine-grained sediment. We can't see really coarsening upwards or fining upwards in these little layers. And they are making up a section which is a little more than 2 meters in height. So the next question then, after looking at the sedimentology very quickly through this section, is what kind of methods could we use to determine when this was deposited? And so I brought my really good friend, my mentor and good friend. He's a guru of quaternary geology in Nova Scotia. His name is Ralph Stay. You're going to read at least one of his papers. And what I was wondering, Ralph, is how would you go about dating this? Have you ever dated beds like this?
Well, unfortunately, we don't have any material to date in these sediments. Normally, you find many sections like this would have shell fragments that are remaining still preserved after being deposited with the delta many thousands of years ago. So in deltas further to the west, we have shell fragments in the clay beds of this delta. And you can use those shell fragments to get radiocarbon dates and date the actual age of the delta. Unfortunately, in this delta, we don't have any shells, and we haven't been able to find any. But there are, occasionally in some deltas in Nova Scotia, we do have shells, and we can use those shells to get a radiocarbon date.
And where do you find the shells?
Find them in the clay beds those represent the quiet water deposition in winter. The coarse sand beds represent the rapid deposition of sand-sized grains in the summer. So more melting in summer, sand layers, quiescent conditions in winter, clay beds. And with those clay beds you get shells. Unfortunately, there's acid water comes through the groundwater, which will actually dissolve the shells in these deltas. And the only thing left after these shells are dissolved is the protein lining of the shells called the periostracum. And we can actually date using AMS methods on very, very small samples. So we have dated some of these deltas in Nova Scotia, one of them at Spencer's Island, which is maybe 20 kilometers west of here, dated at about 14,000 to 13,000 radiocarbon years before present.
So that would be about, say, 15 to 14?
15, yeah, exactly. 15
real
to 14,
years?
yeah.
Okay.
Calibrated years, yeah.